There are several types of machine learning models, each with its own strengths and weaknesses. Some of the most common machine learning models include supervised, unsupervised, semi-supervised, and reinforcement learning. In supervised learning, the computer is trained on labeled data or data that has been labeled with the correct output. Supervised learning algorithms include linear regression, logistic regression, decision trees, random forest, support vector machines, and neural networks. Linear regression is a simple supervised machine learning algorithm that is used to predict a continuous value based on one or more input variables. The goal of linear regression is to find the line that best fits the data. Once the linear regression model has been trained, it can be used to make predictions on new unseen data. Logistic regression is a supervised machine learning algorithm that is used to predict a binary outcome, yes or no, based on one or more input variables. Decision trees are a type of supervised machine learning algorithm that is used to make decisions by breaking down a problem into smaller, simpler decisions. It is a flowchart-like tree structure, where each internal node represents a feature or attribute, each branch represents a decision rule, and each leaf node represents the outcome. The process of building a decision tree starts at the root node of the tree, which represents the entire dataset. At each internal node, the algorithm selects the feature that best separates the data into the different classes. Once the best feature is selected, the algorithm splits the data based on the feature's values and creates a new internal node for each possible value. The process is repeated recursively for each internal node until all the data is classified or a stopping criterion is reached. A decision tree can be easily interpreted, as the decision rules are represented by the branches of the tree, and the outcomes are represented by the leaves of the tree. The basic idea behind random forest is to create multiple decision trees, each trained on a different subset of the data, and then combine their predictions to make a final prediction. The process of building a random forest starts by selecting a random subset of the data and training a decision tree on it. This process is repeated multiple times, each time selecting a different random subset of the data and training a new decision tree. Once all the decision trees are trained, the final predictions are made by averaging the predictions of all the decision trees. This method increases the diversity among the decision trees and thus reduces the correlation between them. Support vector machines are a type of supervised machine learning algorithm that is used for classification tasks. SVMs work by mapping the input data into a higher dimensional space, called the feature space, where it is easier to find a decision boundary. Some of the most common types of SVM algorithms include linear SVM, nonlinear SVM, and soft margin SVM. Linear SVM is used when the data is linearly separable, or in other words, it can be separated by a straight line. Nonlinear SVM is used when the data is not linearly separable. Soft margin SVM is used when the data is not perfectly separable. Neural networks are a type of supervised machine learning algorithm that is inspired by the structure and function of the human brain. Neural networks can be used for a wide range of tasks, including image recognition, natural language processing, and anomaly detection. A neural network is composed of the input layer, hidden layers, and output layer. The input layer receives the input data and passes it on to the next layer. The hidden layers are responsible for processing the input data and extracting relevant features. The output layer produces the final prediction or output of the neural network. Some of the most common types of neural networks include feed-forward, recurrent, convolutional, and generative adversarial. Feed-forward neural networks are the most common and are composed of an input layer, one or more hidden layers, and an output layer. Recurrent neural networks are used for tasks that involve sequential data, such as time series or natural language processing. They have a feedback connection that allows information to flow from the output layer back to the input layer. Convolutional neural networks are used for image and video recognition tasks. They are composed of an input layer, one or more convolutional layers, one or more pooling layers, and one or more fully connected layers. Generative adversarial networks are used for generative tasks, such as image synthesis or text generation. They are composed of two neural networks, a generator and a discriminator. The generator produces fake data, and the discriminator tries to distinguish the fake data from the real data. Unsupervised machine learning is a type of machine learning where the model is not provided with labeled data, and the goal is to find patterns or structure in the data without any prior knowledge of the outcome. Unsupervised learning is used to discover hidden structures or patterns in data and can be used for tasks such as clustering, dimensionality reduction, and anomaly detection. Clustering is an unsupervised learning technique that groups similar data points together. The goal of clustering is to divide a set of data points into a predefined number of clusters, such that the data points within each cluster are more similar to each other than they are to data points in other clusters. The goal of dimensionality reduction is to transform the high-dimensional data into a lower-dimensional space, making it easier to visualize and understand the underlying patterns in the data. Anomaly detection, also known as outlier detection, is a technique used to identify unusual or abnormal data points that deviate from the expected patterns in a dataset. These data points, called anomalies or outliers, can be indicative of errors, fraud, or other unusual events that may require further investigation. Anomaly detection can be applied in various fields such as network intrusion detection, fraud detection, and monitoring manufacturing processes. It is also becoming increasingly important in the area of cybersecurity as it can be used to identify unusual network activity that could indicate a cyber attack. Semi-supervised machine learning is a type of machine learning that combines the strengths of both supervised and unsupervised learning. It is used when the amount of labeled data available for training a model is limited, but there is a large amount of unlabeled data that can be used to improve the model's performance. The model is then fine-tuned using the unlabeled data to improve its performance. There are several different approaches to semi-supervised learning, including self-training, multi-view learning, co-training, and transductive learning. Self-training is an approach to semi-supervised machine learning that involves using a small amount of labeled data to train a model, and then using the model's predictions to label the unlabeled data. The newly labeled data is then used to retrain the model and improve its performance. Multi-view learning is an approach to semi-supervised machine learning that involves training multiple models on different subsets of the data, and then combining their predictions to make a final prediction. Co-training is an approach to semi-supervised learning that involves training two or more models on different subsets of the data and then using the predictions of one model to label the data for the other model, and vice versa. The idea behind co-training is that by using the predictions of one model to label the data for the other model, the models can learn from each other and improve their performance. By training a model on each feature space and then using the predictions of one model to label the data for the other model, the models can learn from each other and improve their performance. Transductive learning is an approach to semi-supervised learning that involves making predictions for the unlabeled data based on its similarity to the labeled data. The idea behind transductive learning is that the similarity of the unlabeled data to the labeled data can be used to infer its label. Reinforcement learning is a type of machine learning where an agent learns to make decisions by interacting with its environment. The agent receives rewards or penalties for its actions, and uses this feedback to adjust its behavior and improve its decision-making over time. There are two main approaches to reinforcement learning: value-based and policy-based. The value-based approach in reinforcement learning is a method for learning a value function, which estimates the expected cumulative reward for each state or state action pair. The policy-based approach in reinforcement learning is a method for directly learning the policy, which is a mapping from states to actions. The policy or actor is updated based on the value function or critic. The actor updates its parameters based on the gradients of the value function. Policy-based methods are more sample efficient than value-based methods and can learn policies in high-dimensional or continuous action spaces. Click like and subscribe if you want more videos.